Welcome to Catch This. My name is Trudy Ray. I wanted to make you aware that I also write for a blog called Virology Blog, where I publish on the first Thursday of every month. Please be sure to check that out. Alzheimer's disease, also referred to as AD, is a neurodegenerative disorder and the most common form of dementia. Although its exact cause is unclear, an increasing body of evidence suggests that an infection with Herpes Simplex virus, or HSV, may contribute to onset of AD later in life. Both types of HSV, HSV1 and HSV2, infect cells of the skin and mucous membranes, where they establish a lifelong persistent infection in sensory neurons. Exposure to various stressors triggers their sporadic reactivation, and the resulting viral particles can eventually reach the brain and lead to a variety of downstream effects. In this video, I will describe some of the evidence that suggests a link between HSV and AD. Don't go away. Post-mortem analyses have revealed that the brains of patients with AD contain abnormal clusters of two types of molecules, amyloid beta and tau protein. Amyloid beta is about a 40 amino acid long peptide that normally has various regulatory functions, including a protective antimicrobial role in innate immunity. However, in the context of AD, amyloid beta peptides appear to misfold and form extracellular aggregates known as amyloid plaques. It is possible that infection with some viruses activates amyloid beta's immune functions, but causes it to misfold and form plaques. Tau protein typically binds to and stabilizes the microtubules that provide structural support in healthy neurons. However, in patients with AD, tau proteins detach from microtubules and bind each other inside neuronal cells, forming aggregates known as neurofibrillary tangles. Collectively, amyloid beta plaques and tau protein tangles can interfere with neuronal functioning and synaptic communication, ultimately leading to cognitive decline. German physician Alois Alzheimer initially described AD in a 1906 case reported on a 51-year-old woman with dementia. Alzheimer noticed similarities between AD and neurosyphilis, an infection caused by the bacterium Treponema pallidum, leading to the idea that AD may have a pathogenic origin. Later on, in 1980, an article in The Lancet proposed a possible link between HSV1 infection and AD in people who also carried the ApoE4 gene. ApoE4 encodes a subtype of the apolipoprotein E protein, which regulates the metabolism of fats in mammals. The authors of a paper published in 1997 analyzed the brains of individuals who had died from AD and compared them to the brains of people who had died of non-AD related old age. The frequency of ApoE4 was much higher in AD patients who were also infected with HSV1 than among HSV1 negative AD patients or individuals who had neither AD nor HSV1. This observation gave credence to the 1980 Lancet article and suggested that individuals who had both HSV1 in the brain and the ApoE4 gene were at higher risk of developing AD. Fast forward to today, a recent prospective study from Sweden aimed to determine whether HSV infection in older people who have the ApoE4 gene can be used to predict the risk of AD and dementia. The investigators initially assessed about 1,000 randomly selected dementia-free individuals around their 70th birthday. They collected their blood samples and assessed their dementia AD status every 5 years for a total of 15 years. They found that when compared to control individuals who had not been infected with HSV, HSV-infected people appeared to have a doubled risk of developing general dementia not necessarily related to AD, regardless of whether they carried the ApoE4 gene. Now, remarkably, the study did not show a significant association between HSV status and AD specifically. Also, those who were positive for HSV and received antiviral treatments did not have a reduced risk of developing AD or dementia, suggesting that antiviral treatment after infection with HSV may not protect from a future diagnosis of dementia. However, as with all previous research in this field, the results of the study are merely correlative and do not define a mechanism that clearly shows that HSV infection causes dementia or AD. Some studies done in mice offer some convincing evidence for a causal relationship between HSV-1 infection and AD. One publication showed that mice that are initially infected with HSV-1 and then subjected to 7 consecutive heat stress-induced reactivations of viral replication. Remember, stress triggers reactivation of HSV. The study showed that those mice have significantly higher accumulation of amyloid beta and tau protein in the brain, and that this was coupled with increasing cognitive defects compared to uninfected control mice. Now, such observations in mice are not necessarily predictive of outcomes in humans, but they do offer some valuable insights, particularly when considering that similar studies cannot be done in humans. If HSV does indeed contribute to the development of AD, it is unclear why only a small minority of people develop dementia, even though about 95% of people become infected with HSV-1 and or HSV-2 at some point during their life. This disparity reminds me of a similar association between Epstein-Barr virus infection and multiple sclerosis, which for several decades was also only an epidemiological correlation. Like HSV, EBV infects about 95% of adults, yet most people never develop MS. Nevertheless, recent studies have identified a convincing molecular mechanism that implicates EBV infection as a causal factor in the development of MS. Those studies were discussed in episode 35 of Catch This, linked above. Considering these developments in the field of MS, it is possible that additional studies may enable researchers to disprove or confirm the hypothesis that there is a causative link between HSV and AD, especially if a mechanism of action can be established. That's it for today. Thanks again for listening. My name is Trudy Ray, and I'll see you next time on Catch This.